Hi guys. Okay. Here's our lesson for 4-6. Our sponge, our warm-up activity. Let's look at function A and function Q. This is what we did yesterday. So in function A, if I want to know the function rule, that's our y equals mx plus b. The first thing I actually have to do is my rate of change. That's the first thing I need to do. So I'm seeing that my y column is counting by 3s and my x column is counting by 2s. So that gives me a rate of change of 1.5. So I can start writing my function y equals 1.5 times x. But the second thing I need to know is my initial value, or my starting amount, which is the number across from 0. Well, darn it, the table does not have a 0 in it. But if I backtrack through the data, 8, 6, 4, 2, the very next value in the chart would have been a 0. So I'm going to backtrack through the y side, 14, 11, 8, 5, counting back by 3s, and that would be a 2. Okay? So that would make plus 2 at the end. Alright, function Q, I already have the equation. I'm not trying to figure it out like I was in function A. I just have to know that 3 is the rate of change and 10 is the initial value. I just need to know which of those numbers is which. And then down at the bottom, I'm looking for you to write some sentences. Okay? And these are kind of really Captain Obvious, common sense type sentences. Okay, something along the lines of function. Oh, let's make this a fun color here. Function A has a smaller rate of change than function Q. Okay? Or you could say something like function Q has a higher initial value. Okay? You're just looking at the numbers and comparing, apples to apples and oranges to oranges in terms of comparing rates of change and initial values. Okay, so that's what I'm looking for you to do in your sponge. Our learning target for today is to interpret and draw conclusions from information provided in a graph. Okay, you're going to want to put on your common sense hats today. Alright, when you're looking at a graph, steep lines, we're really focusing on the rate of change of graphs and not maybe specifically what the actual number is, but just comparing when is something happening faster, slower, etc. Steep lines indicate a high rate of change or a high speed. Gentler lines would indicate a slower rate of change. If it is a completely flat line, that would indicate that you're not moving anymore. Things are not changing. You're staying in one place. And a downhill line does not mean you're going down. It means that the speed is you're moving in a direction toward home. Okay? In fact, I want to add those words in here. Decreasing, moving toward home. Okay, or if it's not home, it's some other location or whatever. And if it's a curved line, that tends to indicate that the rate of change is variable. It means it's not the same. It's kind of, variable is a good word. All right, this is a bit of writing, so now might be a good time to pause it and catch up. Okay, this graph, before we even read the questions, let's just look at the graph so we know what it's about. First of all, the title. The title says potatoes consumed. This is about potatoes. All right. I also see that we're measuring the potatoes eaten on various days of the week. Okay. On the side, our y-axis is measuring in kilos. Okay, 1 kilogram. Kilos is short for kilogram. Just for your own reference, a kilogram is 2.2 pounds thereabouts. Okay, so this is saying 15 kilograms on Monday. So this is not the amount, that's like over 30 pounds, well over 30 pounds. That is not the kilograms of potatoes consumed by one person. This might be how many potatoes are consumed by, say, kids at a summer camp or in a restaurant or something like that. So it's not one person. And I want you to just notice things like, gee, the high point seems to be on Sunday. The low point seems to be on Thursday. I mean, these little details of things that you can see in the graph, okay? And then we can start answering questions. What happens between Wednesday and Thursday? Well, let's see. Let me clear out my highlights here. So we're looking at this area from here to here. Okay? The amount of potatoes, let's see, from Wednesday to Thursday is decreasing. Now, when you write sentences, remember to be specific. And you don't have to make up the words. Okay? The words are right here in the problem. The number of potatoes consumed. Decreased. Notice I did not say the word it. It, I'm sure your other classes, English, social studies, have told you never use the word it. Okay, the next question is asking how many total kilos of potatoes were consumed in the whole week. Total means add them up. So Monday is 15, Tuesday is 20, Wednesday is 30, Thursday is 10, Friday is 15, Saturday is 25, and Sunday is 35. Okay, pause the video for a second, take the time, add them up. Okay, if you paused and added everything up, you would get 150 kilos of potatoes were consumed over the week. And the last question, how many more potatoes were consumed between Wednesday and Thursday? Okay, so how many more means subtract. So Wednesday was 30 and Thursday was 10. So 20 kilos more were consumed. I'm running out of room here. Okay. Again, at any time, pause this to catch up with the writing. Okay. Pause, rewind, whatever you need to do. Okay, so this chart, this graph is all about data. It's actually data that I took from my son's growth from when he was 0 to 2 years old. He's 4 now. But I want to take a break from the notes for just a second and show you an important graphic for a second here. All right. Because a lot of students are confusing. They think the longer line means that something is happening faster. Okay. So let's say I have this graph. All right, and I'll have the green section here and the yellow section here. Okay, so we can easily see that the green section is shorter and the yellow section is longer. But what I'm asking about in general in our lessons today is not which is longer. When you're talking about speed, speed means rate of change, means slope, and that means steeper is faster. Steeper is faster. Nothing to do with the length of the line. Okay? Think about it as the difference between a marathon runner and a sprinter. A sprinter runs much faster than a marathon runner because they only have to run for a very short amount of time. So the length of a sprinter's graph would be very short, but it would be very steep because they're running fast. But a marathon runner, they need to conserve their energy. So they're going to run more slowly so that they can run a longer distance. So their line won't be as steep, but it would be longer. Okay? So if this was, somebody running, this is the part of the graph where they are running faster. Okay? It may be for a shorter period of time, but it's steeper. They are running faster. In this part of the graph, they are running slower, just for a longer period of time. Okay? So the length of the line has thrown kids off today. So I want you to realize that we are not focused on the length of the line. We are focused on how steep it is. All right? So going back to our notes. Okay? So this is the growth of my son Landon. And let me get it so that the x-axis shows here. Over a course of, this is 0 to 24 months, so up till he was 2 years old. When was the greatest increase in his weight? Okay, so again, we are not looking for the longest line. We are looking for the steepest line. And the steepest line is right here. And that's between 0 and 2 months. When was the least increase? Here again, guys, I'm not looking for the shortest line. I'm looking for the line that is the flattest, the most gentle hill, which is here at the end. And that's 18 to 24 months. All right, so overall, this next question, what does the rate of growth do over time? Well, the greatest growth was in the beginning and the least growth was at the end. So the rate of growth over time, the growth rate over time is decreasing. Okay, the rate of change, our lines, the lines are getting flatter and flatter and flatter. And obviously we all have experienced life. You guys are all still growing, but when Mrs. Andrews was an 8th grader, I was the same height that I am now. I stopped growing in height after 8th grade. So, growth flattens out, which is a good thing, or we'd all be giants. Okay? All right, let's move on to the next thing. All right, so interpretation. When is Bob standing still? This is a graph about Bob and the minutes he's walking versus how many blocks away from home he is. Okay. He's actually standing still at 2 points in the graph. One is right here and one is right here because those are the flat spots. So 2 to 3. But you could also answer 5 to 7. When is Bob going the fastest? Okay, again, it's not length of line you're necessarily looking at. I mean, it might be, but it's not necessarily. You're looking at the steepest line. So the steepest line is here. Okay, it's a coincidence that it happens to be also long, the longest segment, but it's the steepness that we're paying attention to, and that's from 3 to 5. I'm going to abbreviate BTWN, 3 and 5 minutes. How many blocks from home was Bob after 5 minutes? So I'm just going to, this is simple reading the graph. 5 minutes, 7 blocks. What is Bob doing between 7 and 8? So the part of the graph we're looking at here is 7 to 8. Well, the graph is going down. He's not going downhill. In fact, I'm going to talk about the words uphill and downhill because they are put on your homework to trick you. So what is he doing? Well, what's going down is the blocks from home. So he's 8 or 7 blocks from home here. He's 5 blocks from home here. So between minutes 7 and 8, he is walking home. All right, last thing. All right, given the following information, draw the graph. Well, it's important to know that Bob starts out 0 minutes and 0 miles from home. So we have to start by putting a dot in the origin before we read the clues. We have to start there. And then it says Bob traveled 1 mile in 2 minutes. So 1 mile, 2 minutes, put a dot and connect it. Okay? That's the first clue. The second clue said from minutes 2 through 5, he stopped at a friend's house. Stopped means a flat line from 2 to 5. After 3 more minutes, well, we're already on minute 5, so after 3 more minutes, we're talking about minute 8, so I know it has something to do with 8 minutes. He was 8 miles from home. Okay, so here's 8 miles, 8 minutes, and put a dot. Oh, my mouse, bumped my mouse. For the last 2 minutes, he stopped to take a picture. Okay, stopped, flat line, 2 minutes. Okay, each square represents a minute, so we're going to go across. Okay, between which 2 points in time is Bob going the fastest? Again, this part of the line, not very steep, it's pretty flat. This is completely flat, so he's not going anywhere at all. This part of the line right here is when he's going the fastest, between 5 and 8 minutes. Well, how fast is he going? Hint, rate of change or slope. Okay, slope. So rate of change remember is your change in the y over your change in the x. So let's label some points here. This is 5, 1, and this is 8, 8. So the change in y, he goes from 1 mile to 8 miles. That's a 7-mile difference. Minutes, he's going 5 minutes to 8 minutes. That's a 3-minute difference. 7 divided by 3 is 2.3 repeating. So 2.3 repeating miles per minute. And if anybody is checking the reasonableness of that answer, think of how long a minute is and how fast would you be having to go in 1 minute to travel 2.3 repeating miles. If you multiply 2.3 repeating times 60 to get miles an hour, it's 140 miles an hour. I'm going to guess that Bob is some sort of superhero with super fast speed. Okay, homework. I want to go over a couple things in the homework. Okay, first of all, read some for your context clues. Elvis takes 3 hours to drive to his friend's house 60 kilometers away. Okay, so first of all, we're talking about hours and kilometers. So we could basically, for question 1, eliminate things that are not in those units. So this one says time in seconds, so nope. Hours, 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 hours. Okay, kilometers. That's kilometers. This one's miles, so that's not it. Kilometers, kilometers, kilometers. Okay, so we've already eliminated 2 graphs just because it's not even the right units. All right, so now we're going to look at numbers. Elvis takes 3 hours to drive to his friend's house 60 kilometers away. All right, so let's look at the graphs and see if we have a point at 3 and 60. So 3 hours. In graph B, there's nothing going on at 360, so it's not graph B. Graph D, 3 hours is not even on graph D, so that's not it. Graph E, 3 and 60, winner, winner, chicken dinner. We have the graph that matches right here. Okay, and just to look at F for a second, 3 hours and 60. Again, nothing going on there, so it's not F. Okay, so number 1 is E. Once you've used graph E, you are now done, and you will not use E again. Okay, every graph is only used once. Now, I also want to point out that there are some things in here to trick you. For example, it talks in number 2 about Nora, and I know it might be hard for you to read it on the screen, so read it on your paper. Nora cycles home downhill for 18 kilometers over 15 minutes. Guys, I'm going to tell you right now, words like downhill and uphill are in there to throw you off because it's trying to make you look for graphs that go down and then up. Don't do that. First of all, there is not a graph in here that goes down and then up. What you're really reading for is towards home, and again, towards home, and then there's a stopping point in the middle. So towards home is a keyword that would mean going down, that you're not down, I want to get away from that word. You're looking for a graph that's decreasing, stops, one that's flat, and towards home, I'm looking for another decreasing again. Okay, I know it says uphill. That's a word in there to trick you. Okay, if you ride a bike downhill, you're going to ride your bike a lot faster downhill than you are riding it uphill. Your speed will be greater riding it downhill than uphill. So that's not what we're getting at. The uphill and downhill thing is put in there specifically to trick you. Okay. The other homework thing I wanted to remind everybody about is number 7. Before you read the first clue about Fred, remember that you need to put a starting dot here at 0, 0. Okay, Fred starts at home or at the train station or whatever. Fred goes on a train 1 hour from Hull to Leeds. Those are just 2 city names covering 60 miles. So 1 to 60. There's my next dot. And then you would connect those and keep reading the clues, making more dots and connecting. Okay? Thanks for watching. See you next time.